I am an avatar organized by Dr. Alemi to deliver this lecture. This presentation reviews treatment of missing values. A well-kept secret of regression analysis is that all of the independent variables are selected to work together. When one is missing, the entire regression formula is useless. The purpose of this presentation is to show you how you can treat missing values so that regression equation can be used to predict the outcome of interest. Variables can go missing in two ways, at random or not at random. If information is missing at random, there are less concerns about how the missing variable is treated. Let us look at an example. In this study, when blood pressure was missing, it was not at random, it increased the risk of mortality. The first step is to detect if the variable is missing at random. To test if X is missing at random, first set the value of an indicator variable to 1 wherever the value is missing and 0 otherwise. Then regress the response variable on the binarized indicator variable for missing X values. In the last step, test if the coefficient of the indicator is significantly related to the response variable. Let us look at an example. There are 19 body systems names BS2LR to BS19LR. For each of these variables, we have created an indicator variable that is 1 when the variable is missing, and 0 otherwise. For example, the first variable is an indicator variable that is 1 when BS2LR is missing, and 0 otherwise, and we have called it BS2LR binary. The response variable was regressed on the indicators. The stars next to the line shows if the indicator variable was significant predictor of response variable. One of the variables, binary variable for body system 15, is missing everywhere, and the regression was not able to process this variable. Drop this variable. Variables that are significant predictors of response are said that they are not missing at random. Variables that are not significant predictors of response are missing at random. Now that you know if a variable is missing at random or not, you can decide how to adjust for it. If the dependent variable is missing, drop it from the analysis. No ifs or buts. If you estimate the missing dependent variable from other variables, you would be creating a bias in the data. There are multiple methods for addressing missing independent values depending on whether the variable is missing at random or not at random. If information is missing at random, there is very few concerns about how the missing variable is treated. When data are missing at random, deleting the case has no impact on the relationship between independent and dependent variables, but will reduce the sample size. Another option is to replace missing values with mean, mode, or median. In R, you do this through a package called MICE. Mean imputation is a fast and simple fix for the missing data. However, it will underestimate the variance, disturb the relations between variables, bias almost any estimate other than the mean. Regression imputation replaces missing values of X with predicted value from regression of X on other independent variables. In R, you can do this through MICE as well. You use the option of predictive mean matching in MICE package. The parameter 5 tells MICE package to do this 5 times from random samples of the data and take the average of imputed values. Imputation strengthens the relations in the data. Variability is underestimated. It reduces drift in applying the model to other data. You must check accuracy of your adjustments in cross-validation. When the missing values are not at random, then you include the missing value indicator like all other independent variables in the model. Here is an example that highlights how patterns of missing should be analyzed. MICE package gives you visual display of where variables are missing together. In this plot, red indicates a case in which the data is missing. Blue indicates that there is a value present. Look at the pattern of missing across indicators and see if the common denominator of the indicators can explain a lot of the missing red cells. For example, we see that the last row has a lot of missing, but the common set of missing is to the right, where it is missing from first to the last row in this portion of the data. This is where you can come up with an interaction among indicators of missing values. Patterns of missing provide information for unique types of adjustments. These interactions need to be tested in cross-validation. Missing variables can be addressed in different ways, but you need to pay attention to if they are missing at random and whether there are patterns among missing indicators. Thank you. I hope my presentation was clear.